So we are dividing polynomials. If you look at the first two, those are monomials, which on the denominator. See how there's only one term, there's no plus or minus? We like these are easy, okay? What I want you to realize, if you look at number 1, this is the same thing as writing it like this. These are equal. Okay, I just separated my denominator, right? Okay, so when you have a monomial on the bottom, you want to separate your denominator and simplify. So here, 3 divided by 3 is 1, but we can cancel them. The C's match, so those cancel. Where are there more A's? On top. So 2 minus 1 is 1, or just A. So you can put A, or you can put A to the first power, right? Now look at this second one. What do I get? 2 A squared C, because 2 minus 1 is 1. Plus, what's 18 divided by 3? 6. And then what happens to the A and the C? And so there's my answer. Now, is it in proper order? No. What would it be proper order? Okay, so there's my answer. Now, if you hate rewriting everything, especially when they get to be more terms, you can just kind of separate with some lines. So this would just be 6x squared y. And simplify like that. Okay, because I know that y'all hate rewriting things. So that's fine, but I do want you to rewrite your denominator, because sometimes when kids don't, they forget and they'll start crossing things out, and then they won't divide everything by the same thing. So what's 12 divided by 6? 2. Now, where are there more x's? Top. And how many do I have left? Okay, where are there more y's? Top. And how many do I have left? 3. Plus what? Yeah, because 48 divided by 6 is 8. 5 minus 2 is 3. 3 minus 1 is 2. And they were all on top, more on top. Now, what about negative 9 divided by 6? If you type it on your calculator, it's going to give you a decimal, right? And an ugly decimal at that. So you have to leave it as a fraction. So I know it's going to be a minus or a negative. And what does it simplify to?
Negative 3 over 2.
3 over 2. Now, where are there more x's? On top. And how many do I have? 3 minus 2, so just 1. And then where are there more y's? Top. And 2 minus 1 is 1. So I don't have to put the 1's. Now, last one. What's negative 18 divided by 6? Negative 3. Where are there more x's? The bottom. How many do I have left? Yeah, 2 minus 1 is 1. And the y's match, so they cancel. So here's my answer. So usually, you're going to see more problems that look like number 1, but they don't all have to simplify to a non-fraction. Okay? It's okay if there's still a fraction. Any questions with those with monomials on the bottom? No plus and minus on the bottom. Okay, so when you get to problems like these that do have a plus and minus on the bottom, the big thing to remember is that you cannot be missing any degrees. And I'm going to explain what that means, so don't worry. But if you look at the first one, what's my highest degree on top? 2. So 2, this is a degree of 1, and this is a degree of 0. Was there anything missing in between? No. Now, if it went from 2 to 0, I'd be missing a degree of 1, right? That's what I mean by that. And you can't be missing a degree on top or bottom. Okay, so on the first two, I'm not missing any degrees, so we don't have to worry about it yet, but we'll talk about it when we get to example 5, okay? So knowing that, we have to set this up as long division is the way we're going to do it. You can't just separate like that because it has a binomial on the bottom. You have that plus sign. So this is super corny, but this is how I was taught when I was younger. But we're going to refresh ourselves with long division. So if I have 2 divided, 396 divided by 2, what do you do for long division?
It'll be like, we'll just have 2 going into 3.
Well, 2 goes into 3 how many times?
0.
1. 1 times 2 is 2, and then we would do what? Subtract and find out what we had remaining. What's 3 minus 2? 1, and then what did we do? Bring down the 9. Does 2 go into 19?
Yes.
How many times? 9 times. What's 9 times 2? 18. Subtract. That leaves me with 1. Bring down the next number, 6. 2 goes into 16 how many times? 8. 8 times 2 is 16. Subtract. I have a 0 remainder, so my answer is 198. Okay? This is important to remember because it's going to help us, kind of reminding us what long division used to look like, because that's kind of the route we're taking. So I'm going to leave that there. And then this is what I was saying was corny. When I was younger, they taught us the cowboy rides the horse, right? Cowboy on top, horse on bottom. Cowboy goes inside. Horse stays outside. So x plus 3 stays outside. So the top goes inside the house, bottom stays outside the house. That's all that means. So when we did this here on our sticky note, we looked here, here, and that's how we found our 1, right? So same concept. We're going to look at the x squared, and that's how we're going to find this. Now, we technically divide. You can think of it as multiplication, like x times what gives you x squared. But I prefer division, so x squared divided by x. Well, isn't that just x? Yes. And then, didn't we multiply 1 times 2 to get this number? So same concept. We're going to do x times x is x squared. But we also have to not forget about that 3. So x times 3, so that's positive 3x. So I just multiplied times both. Now, what did we do next? We subtracted. Now, we have to subtract both. However, what I want you to realize, y'all, is subtraction makes everything look opposite, right? If I put subtraction in front of a positive, doesn't it now look negative? And if it was negative, 2 negatives makes a positive. So every time I say subtraction, I'm going to say opposite, opposite, because that's what it is. So these are both positive. They both become negative for subtraction. Well, that first term, with the way we're doing this with polynomials, it should always cancel. Well, x squared minus x squared is 0. What's negative 5x plus negative 3x? Negative 8x. Now, after we did that, what did we do next? We brought down our next term. So the key thing to remember is if we have 2 terms here on the outside, we need 2 terms at the bottom at all times. Okay? So what?
How'd you get 8 again?
Negative 5 plus negative 3. So now we're looking here, here, and here. So again, you could think of it as x times what gives you negative 8x, but I like division, so negative 8x divided by x, so inside divided by outside. And what happens to those x's? They cancel, and what does that equal? Then what did we do? We multiply, right? 9 times 2 is what we did. So negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. And then what? We subtract. So that means opposite, opposite, and they both became positive. Well, negative 8x plus 8x is 0, and negative 24 plus 24 is 0. So I have no remainder, and what's my answer? Yes. Because when we subtract, it was negative, but when you subtract, two negatives makes a. So that's why we make it opposite, opposite. Okay, so let's look at example 4. Now, what is happening here? Yeah, but what kind of exponent does it have? Because I have to do exponents before I can multiply. And negative 1 means I have to make it a fraction and move it. And when I move it, now it's positive 1. But do I need a positive 1 exponent? So is that just a fancy way of saying divide? Yeah. 100%. That's all that it's saying. Okay? So knowing that, what goes inside my house and what goes outside? Top goes inside. Bottom goes outside. So inside divided by outside just gives me x. Then what? The multiply. So x times x. X times negative 4. And then what? Subtract. So opposite, opposite. Okay, so x squared minus x squared is 0. And what's negative 11x plus 4x? Okay, so now I'm looking here, here, and here. So negative 7x divided by x. Well, x's cancel, so it's just negative 7. So negative 7 times x. Now, oh, sorry, what did I forget to do? Bring down my minus 3. Now I multiply. Negative 7 times x is negative 7x. Negative 7 times negative 4 is what? Positive 28, because two negatives makes a positive. Now, what I want you to realize, y'all, when you bring down your last thing, you know this is your last step, which is exciting. Okay? So now what? Opposite, opposite, because we're going to subtract. So subtract, well, two negatives makes positive, positive minus. This zeroes out, which is what we want to happen. And this gives me negative 31, but I can't keep going. So what do we call this? Do y'all remember? The remainder. Don't stress when you have a remainder. All you do is put a plus sign and a fraction bar. Your remainder goes on top, and whatever you divide it by goes on bottom. So our final answer here is x minus 7 plus negative 31 over x minus 4. Now, technically you could have just made this a minus and not had that negative there. The reason I say that, you'll see on the next one, it's just easier to always do plus and then keep the sign with it so you don't make any tiny mistakes. Any questions so far? Okay, let's look at the last one. Okay, so again, we have to check. This one has a lot more than those other two. We have to make sure that we're not missing any degrees. So if the top, what's my first degree?
4.
Then what?
3.
Then what?
2.
Then what?
1.
Then what?
0.
So was it missing anything? No. 4, 3, 2, 1, 0, we're not missing anything. But look at the bottom. 2, And then what?
0.
What is it missing?
1.
It's missing a degree of 1, so we have to put a placeholder. Well, the only thing that you can add that doesn't change anything is what?
X.
No. If you add 1x, that changes it. That changes it. 0. Now, can I put an x behind my 0? Yeah, it's still 0. 0 times anything is 0, right? So I can put my plus 0x in there. So inside the house is the top. And outside the house is going to be 2x squared plus 0x minus 3. Now, if I were missing a degree on the top, I would do the same thing. I would have just, like, say there was no cubed, I would have done 4x to the 4th plus 0x cubed minus 4x squared. And it's just a placeholder, y'all. It doesn't change anything. It's to make sure all of our like terms still line up. So there's 3 terms here now, but we still treat it the exact same way. Don't let that stress you out. It actually makes it divide faster because you do 3 terms at a time instead of 2 terms at a time. So we kind of prefer this. Okay, so first things first. So remember, inside divided by outside. So 4x to the 4th divided by 2x squared. What does that give me? 2x squared. 4 divided by 2 is 2, and then we subtract. So 4 minus 2 is 2. What do we do after that? Multiply. So 2x squared times 2x squared, well, 2 times 2 is 4. X squared times x squared, we add. 2 plus 2 is 4. What's anything times 0?
0.
So is it okay if I just put 0? Does it matter what my letters are? No. And what's 2x squared times negative 3? So the reason we had that 0 there is because if not, I would have had minus 6x squared lined up with my x cubed. And can we combine those? That's why we have that placeholder. Because now it kept my like terms aligned. Yes? Okay. What do we do next? Subtract. So opposite, opposite, opposite. First term cancels, which is what we want to happen. Negative 10x cubed minus 0. Does that change anything? No, it's just negative 10x cubed. What's negative 4 plus 6? Positive 2x squared. And now what? Bring down my next term. Because there's 3 terms here, I need 3 terms here. So now we're looking here, 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 sorry. Okay, so negative 10x cubed divided by 2x squared. What's negative 10 divided by 2? And then we subtract x from it. So 3 minus 2 is 1. So negative 5x times 2x squared. Well, negative 5 times 2 is negative 10. X times x squared is x cubed. Negative 5x times 0 is 0. And negative 5x times negative 3. 2 negatives makes 8. Now what? Yeah, opposite, opposite, opposite. This cancels. This comes down. And what does that give me? Negative 3x. Now what? Bring down my minus 8, which is my last one, which means this is our last round. Okay? So now I'm looking here, here, and still here. So inside divided by outside, well, what happens? When everything cancels, what does that equal? No, 1. So this is just plus 1. Well, we like that because when you multiply by 1, does anything change? No. 1 times 2x squared is 2x squared. 1 times 0 is 0. 1 times negative 3 is negative 3. Are we going to have a remainder? Yeah. The only time you can tell when there's no remainder is when everything matches at this point. But it doesn't all match, so we're good. So opposite, opposite, opposite. This canceled. Bring down my negative 3x. And what does this give me? Negative 5. So this is my remainder. Because there were 3 terms, it's okay to have a 2-term remainder. As long as your remainder is smaller than your denominator, what you divided by, which is 3 terms, you're good. So remember, plus sign, fraction bar. And then you don't have to include the 0x here, though. So just 2x squared minus 3. Okay, so you do have a practice.